discrete mathematics, I already discussed chapter 1, it's about logic. Then chapter 2, set theory. Chapter 3, graph theory. Next chapter is combinatorics. In combinatorics, I will discuss counting, recurrence relation, and genetic function. In detail, chapter 4 contains the basic of counting, permutation and combination, the pigeonhole principle, inclusion, exclusion, recurrence relation, and genetic function. So we'll start with the basic of counting. In basic of counting, there are two rules. One is product rules, another is sum rule. First, I will discuss the product rule. Product rule. Suppose we have two tasks T1 and T2. T1 we can do in N1 way, T2 we can do in N2 way. Both T1 and T2 are different tasks. Okay, they are separated tasks. They are not dependent on each other. Then total how many way we can do T1, T2 equals to N1 multiplication N2. And remember, T1 and T2 are separate tasks. Now let's see one example. Example 1. The chairs of an auditorium are to be labeled with an uppercase English letter followed by positive integer not exceeding 100. What is the largest number of chairs that can be labeled differently? There are 26 uppercase letter, and with each letter we can add 100 numbers. So in total how many chairs we can arrange? So 26 multiplication 100 is 2600. So total 2600 chairs we can arrange by using 26 alphabet and 100 numbers. Now extended version of product rule. Here we just used two tasks. Suppose there are multiple tasks. Let T1, T2 till Tm, and each task can be done in Ni way. Then total N1 multiplication N2 multiplication till Nm way we can do the procedure. Suppose T1 will be in N1 way, T2 will be in N2 way, Tm will be Nm way. We can multiply all the way and we'll get how many way we can do the total procedure. Next example 2. How many different bit string of length 7 are there? So we have length 7, and how many different bit string can be possible on length 7? So in each place there can be either 0 or 1. So total 2 power 7 bit strings possible. 2 power 7 is 128. So total 128 different bit strings of length 7 are possible. Next, example 3. How many different license plates can be made if each plates contain a sequence of 3 uppercase English letter followed by 3 digits? So there are total 6 length. Okay, so first 3 can be alphabet, uppercase alphabet, and next 3 can be any digit. So here 26 possibility, it can be any alphabet, and these 3 there are 10 possible. It can be any digit from 0 to 9. So just multiply 26, multiply 26, multiply 26, multiply 10, multiply 10, multiply 10. It's 1757600. So this many license plates possible. Next example 4. Counting functions. How many functions are there from a set with m elements to a set with n elements? So we have a set having m elements, we have another set having n elements. It is asking how many possible functions are possible from a set with m elements to a set with n elements. It will be n power m. N will multiply m time, it's n power m functions from a set with m elements to another set with n elements. Suppose there is a set with 3 elements and there is another set with 5 elements, then how many functions possible from a set with 3 elements to a set with 5? It will be 5 power 3. So 5 power 3, it will be 125. I already discussed this as a formula during function. Just go through that lecture. Next example 5. Counting one-to-one functions. How many one-to-one functions are there from a set with m elements to one with n elements? So first of all, for one-to-one function, m cannot be greater than n. So if m is less than equals to n, then only one-to-one functions possible. Suppose we have domain like a1, a2 till am, right? So for a1, let here b1, b2 till bn. Now for a1 there are n possibility. For a2 there are n minus one choice. For one-to-one function, two elements cannot map to a single element, right? So with which element A1 map, A2 cannot map. Next, for AM, N minus M plus 1. Total number of one-to-one functions possible from a set having m elements to a set with n elements will be multiplication of all these. So n multiplied n minus 1 till n minus m plus 1. So there are n multiplied n minus 1 multiplied n minus 2 till n minus m plus 1 one-to-one functions from a set with m elements to a set with n elements. So for example, 5 multiplied 4 multiplied 3. 60 one-to-one functions from a set with 3 elements to a set with 5 elements. Suppose you have a set A, another set B. A contain 3 elements, let X, Y, Z. B contain 5 elements, let 1, 2, 3, 4, 5. So for X there are 5 possibilities. X can map with anyone, right? So here 5. For Y there are 4 possibilities. For Z there are 3 possibilities. Suppose X map with 2, then Y can map with 1, 3, 4, 5. 4 possibility, let Y map with 1. Then Z can map with 3, 4, 5. Let Z map with 5. So total 60 one-to-one functions possible from a set with 3 elements to a set with 5 elements. So in today's lecture I discussed what is product rule with some examples. In next lecture I will discuss sum rule. If this lecture is helpful for you, please like, share and subscribe. Thank you.